students, this is Dr. John, your physics and math professor, and today we have another force and friction equation. Specifically here we have a toboggan that is being pulled on frictionless snow. The toboggan and rider have a mass of 85 kilograms. I've illustrated that for you here with my high quality illustration. 85 kilograms, these two together, and their acceleration is 3.0 meters per second. We're supposed to solve two different things. Find the applied force. Find the force that is applied by this person who's pulling or pushing the sled. And then secondly, what if they hit a patch of gravel which has a force of friction of 180 newtons? Find the new acceleration, which you would think would be less than this acceleration. So let's just work through this one piece by piece. First of all, we're going to quickly review Newton's three laws. Well, Newton's three laws, the first one is just this. It's sort of the law of inertia. If something's sitting still or moving at a constant velocity and there's no external forces, it's going to continue to sit still or move at that same velocity. What I mean by external forces is I mean unbalanced external forces or net external forces. So there might be a force to the right, but also a force to the left, and those are the same. And if those are the same, it's going to continue to move. And that, the second law just simply says, what if there is an unbalanced force? What if there's more forces ahead than backwards? Well, in that case, the acceleration or the force, the net force, that is add up all the forces, subtract the ones going backwards, the net force is going to be equal to the mass times the acceleration. The higher the mass, the less the acceleration. And the third one of Newton's laws is a little bit unusual. We're not going to use that in this one. And that is for every force, there's an equal and an opposite force. Forces come in pairs. They come, if you're pushing on the wall pushes back. If I'm holding this marker between my fingers, I can feel the pressure of the marker on my fingers as well. Every force has an equal opposite force. That's sort of something we can feel naturally, but Newton put it into a formula form. So here we have this thing, and we have this total mass here, and it's accelerating. So that means there is a net, just like Newton's second law, there is a net force in that direction causing it to accelerate. And that acceleration is 3 meters per second. The mass that's being accelerated is 85. So that means the force being applied, specifically the net force, I put a little n there if I want to, is going to be equal to the mass times the acceleration, which in this case is 85 times 3. And that's equal to 255 newtons. So let me write that answer right over here. So the force net is 255 newtons. I'm writing it really tiny. Hopefully you can read that. If you don't, it's right here. 255 newtons. So we've got the first part of that equation there. So now what happens if we hit the gravel and we have an opposing force? So in that case, we're going to have a force this way, just like this, of 255. And then we're going to have a smaller force, but still a force in this direction of 180. So our net force, you can see, is in that direction. When you have forces of friction, they're basically going to always be less than the force that's applied. Well, they could be equal to the force that's applied if they're just holding it still. But in most cases, they're going to be less because it's not going to spontaneously start moving in this direction because of friction. And that gives us the net force in that direction, which, if my math in my head is right, is 75 newtons. Okay, so that's the net force. So how about if I apply here force net is equal to 75 newtons. So I've got the new force net. That's for part B right here. So what's going to be the new acceleration? Well, we again have a net force, Newton's second law, and that is the force net, the new net force, after you've taken friction into account, is going to equal to the mass times acceleration again. In this case, we can divide both sides by the mass, put the mass over here, divide this by the mass, and we're going to get the acceleration is equal to the new force divided by the mass, or 75 divided by this total mass, 85, 0.882. So I'm going to write that right here. The acceleration here, this new acceleration is 0.8, whoops, that's getting a little messy. Let's try again. 0.882 meters per second squared. Now we've done most of it. Let's just check significant figures. All right, so for the first one here, we want to find the net force. For the second one, we want to find the acceleration. Here we have two significant figures. Here we have two significant figures because you've included the 0. You have 2. So let's make these into 2 as well. 255. If we wanted to put that into 2, would be 260. So the force is going to be 260 newtons. That would be the answer for A. And the answer for B would be, instead of 0.882, it would just be acceleration is equal to 0.88 meters per second squared. So when I calculate it, or I would suggest that when you do the calculation, you sort of note how many significant figures there are. 2, keep at least 1 more digit, sometimes maybe 2. Don't go to keeping 10 digits, that's just silly. Keep maybe 1 extra or 2, and then when you're done your final answer, round it off to the same number of significant figures as you started with. So I hope that helped. If it did, like, subscribe, that really helps me a lot, and I will see you in the next video. Bye-bye.